HTTP has used methods like GET and POST for decades. In June 2026, it officially gained another one query. RFC 10008 defines it as a safe, idempotent way to ask a server a structured question. But why did the web need a new method just to search for data? The answer starts with a URL that keeps growing. Simple GET queries are excellent. A category and price range fit cleanly in the URI, stay linkable, and are easy to inspect. Product search gets awkward when we add brands, stock rules, screen sizes, geography, sorting, pagination, full text search, and nested logic. Encoding that structure is noisy. Practical URI limits vary across clients and intermediaries. URI also appear frequently in logs and analytics. It is not the problem, forcing a query language into one enormous URI is. Could we attach that JSON to GET? Some software permits it, but HTTP does not define generally applicable semantics for content in a GET request. That uncertainty matters across a real request path. A client might send the content while a proxy cache framework or server ignores, rejects, or mishandles it. A GET body is not universally forbidden. It is simply not a portable foundation for a structured query whose meaning must survive every hop. So developers commonly use POST for search endpoints. That is practical. Request bodies carry structured data, JSON is readable, and schemas can validate nested filters. The semantic trade-off is visible in the method. POST can represent almost anything. From POST alone, an HTTP component cannot assume the operation is safe or idempotent. POST is not forbidden from retrying or caching, but its generic semantics provide fewer automatic guarantees for a read-only query. Query keeps the structured content and changes the method semantics. The request content and its media type define the query. The target resource, here products, determines the operation scope. Content type is not decorative. A server must reject a missing value or content that is inconsistent with it when request content is present. Most importantly, the method declares that the requested operation is safe and idempotent. Query combines structured request content with read-only HTTP semantics. Safe is a term about requested effects, not security. The client does not request or expect a change to the target resource's state. A query sent over plain HTTP can still expose its content. A costly query can still overload a service. Authentication, authorization, rate limits, and encryption still matter. Safe also does not promise harmlessness, zero logs, or zero operational side effects. It only describes what the client is asking the resource to do. Idempotency matters when networks fail. The client sends a query. The server computes the result, but the connection drops before the response arrives. Because query is idempotent, the client can repeat the same intended operation without requesting an additional state change. Contrast that with blindly repeating in order creation requests. The two query responses still need not be identical. Data, timestamps, and logs can change between attempts. Idempotent means the intended effect can be repeated, not that time freezes. Here is the practical comparison. GET and query are safe and idempotent. POST does not guarantee either property. GET has no generally defined request content semantics. Query and POST expect content whose meaning is defined for the target resource. GET usually puts the query in the URI, query can keep it in content. GET and query responses are cacheable. POST has more restricted cache semantics. Use GET for clean URI-based retrieval, query for structured safe and idempotent server-side queries, and post-Windows guarantees do not describe the operation. Query responses can be cache, but the URI cannot be the whole key. These requests target the same product's resource while asking different questions. RFC 10008 requires the cache key to incorporate the complete request content and relevant metadata, including representation details such as the media type. A cache therefore has to read and process the content. It may normalize equivalent representations only when it understands the format and semantics. That is more involved than a typical GET, and incorrect normalization can return the wrong result. How can a client discover the query formats a resource accepts? A server can advertise them with the accept query response header. This field signals query support and lists accepted media types, such as JSON, PATH, or SQL. A client can also learn supported methods through normal HTTP mechanisms such as options and allow. Discovery tells us what format the resource understands. The application still defines that format's query semantics. A body-defined query can still gain a useful URI. In a successful response, content location can identify a resource holding the result just returned. Location can identify an equivalent resource that repeats the query through GET without resending the content. Those resources may be temporary. A server can also answer with 303C other in a location, directing the client to retrieve the result using GET. The distinction is compact. Content location points to this result. Location can identify the stored query or redirect target. Query is deliberately narrow. It does not make a query cheap, authorize the caller, encrypt request content, or prevent abuse. It does not promise that infrastructure supports the method today. It does not replace GET, replace POST, or define your application's query language. Developers still choose a media type to specify valid operations, validate input, set resource limits, and enforce access control. A new method supplies precise HTTP semantics. It does not design the application behind them. Standardization is the starting line. RFC 10008 is an Internet Standards Track document published in June 2026 at proposed standard maturity. That does not imply universal implementation. Application code, client libraries, runtimes, proxies, caches, frameworks, and servers all need to implement and test the method. A request can be valid at the protocol level and still meet software that has never seen it. Real deployment means testing every intermediary in your path without guessing an adoption date. Return to the product search. GET is ideal while the query remains clear in a URI. POST carries complex content, but the method itself does not declare a safe and idempotent query. Query carries the same structured content while stating the semantics directly. It is not a replacement for GET or POST. It gives complex, read-only operations a method whose HTTP semantics finally match what the application is doing. The useful idea is simple. A structured question can now look like one at the HTTP layer. The body says what to query. The target says where that query applies. The method says the requested operation is safe and idempotent. Caches, retries, and stored result URI can build on those semantics as implementations mature. Would you adopt query today, or wait for broader support?